In this video, I'm going to show you the process of doing what's called completing the square. Completing the square is used to turn any quadratic, a second degree expression or equation, into what's called a perfect square trinomial. So a perfect square trinomial is a polynomial with three terms, trinomial, where the first and the last terms are perfect squares, and the middle term is 2 times the square root of the first item times the square root of the last item. So for example, here's a perfect square trinomial. Notice that the first term, x squared, is a perfect square, meaning that if I take its square root, I still get a whole number. The last term is also a perfect square. And the middle term must always be 2 times the square root of the first term times the square root of the last term. So if we were to check that, that means that for this expression, it would be 2 times, well, the square root of x squared, which is x, times the square root of the last term, 49, which is 7. 2 times x times 7 is, in fact, 14. Don't worry about the sign of the number. So this is a perfect square trinomial. Perfect square trinomials are good because they're easily factored. When you factor a perfect square trinomial, it always factors into one giant parenthesis that gets squared. In the front of each parenthesis, you put the square root of the first term. So here, remember, the square root of x squared was x. At the back of the parenthesis, you put the square root of the last term. So the square root of 49 was 7. And the sign between those two terms is the middle sign from your equation. So in this case, it ends up being a minus. Perfect square trinomials can still be factored using our standard method of what multiplies to 49, adds to negative 14. This is just a faster shortcut to factor using, again, square root of the first term, sign from the middle, square root of the last term. So let's actually look at a few examples of completing the square, turning a quadratic into a perfect square trinomial. So if we take a look at the first equation, x squared plus 6x minus 59 equals 0. In order to complete the square, you should have at least 2 terms, x squared and x. The leading coefficient, meaning the number in front of x squared, must be a 1, which we have. And if there's a constant, if there's a normal number on the side of the equation with your x's, you should start by moving it over to the other side. So for this equation, I'm going to begin by adding 59 to both sides. Now I have x squared plus 6x equals positive 59. Hey, I left that big space there for a reason. So the actual completing of the square is figuring out what number could I add to my polynomial so that this becomes a perfect square. Now, whatever I add to one side of the equation, I have to add to the other side to keep the equation balanced. To determine what number we're going to add here, we always take the middle term, or our b value. So here, b is 6. We find half of b, and we square it. So if b is 6, we're looking at 1/2 of 6 squared. Well, half of 6 is 3. 3 squared is 9. So 9 is the number that we're going to add to both sides of the equation. So I'm going to plug it in to both of these spaces. Now the left side of our equation is now a perfect square trinomial. And we know that to factor a perfect square trinomial, it always factors into one big parenthesis, which gets squared. In the first spot of the parenthesis, we put the square root of the first term. So the square root of x squared is x. In the last spot of the parenthesis, we put the square root of our last term, or the constant, 9. The square root of 9 is, of course, 3. And the sign between our two terms always comes from the middle sign of our expression. So this is going to be a plus. On the right side of the equation, we can combine like terms. So 59 plus 9 is 68. That is the process of completing the square, turning a polynomial into a perfect square, and then factoring that perfect square. Let's look at one more example. So in this second example, we're going to start with the equation x squared minus 12x plus 11 equals 0. To complete the square, we must have a leading coefficient of 1, which we do. We also need to move our constant to the other side of the equation. So I'm going to begin by subtracting 11 from both sides. Then I'm going to make myself the spaces to figure out what number we're going to add to complete the square. To find that number, we always take the middle term, our b value, find 1/2 of that number, and square it. So we're looking at 1/2 of negative 12 squared. Half of negative 12 is negative 6. Negative 6 squared is 36. So that's the number we add to both sides of the equation. Now the left side of our equation is a perfect square trinomial, so we can factor it into one large parenthesis squared. The square root of the first term goes at the beginning of the parenthesis, so the square root of x squared is x. The square root of the last term goes at the back of the parenthesis, so the square root of 36 is 6. And we take the sign from the middle of our expression. This one is going to be a minus. On the right side of our equation, combine like terms. So negative 11 plus 36 is 25. So we have completed the square, turned our equation into a perfect square trinomial, and then factored it. This is exactly the process we do when we're writing the equation of a circle, but we do it twice, once for all of the x terms and once for each of the y terms.